Hey guys, hope you guys are having a good night. Thanks for tuning in. I'm trying to clear my Inspire calculator right now. Crazy thing. Okay, application number 2, got to get going. The box with the lid. Now the previous problem there was no lid. This one has a lid on it, as you can see over here. This would fold up. We would fold on all these dotted lines, fold up. This would be the cover. Two congruent squares are removed from one end of a rectangular 10-inch by 12-inch piece of cardboard. Two congruent rectangles are removed from the other end as shown. Determine the value of x so that the resulting box has a maximum volume. Okay, so determine the value of x. So in this case, we're going to be doing some cutting here again. And it says here that we are going to remove two congruent squares. Well, here's your two congruent squares. So again, we're going to make our x and our x, x and our x. Okay? We know that this is a 10-inch by 12-inch piece of cardboard. So that means that this total length right here is 20. And this total length right here, slow down, Mr. Kramer. I know you're hungry and you want to go to lunch, but we're going to do this right. So 20 inches long, 10 inches wide. Okay, now it says that two congruent rectangles are removed from the other end as shown. So these are the two congruent rectangles. They are removed. Okay. So on these dotted lines, these are all folded areas where we're going to fold up. So this side's going to fold up, 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 and then this is going to be the top. It's going to fold over. Determine the value of x so that the resulting box has a maximum volume. Well, the first thing we need to do here is we're going to slice this in half because this is going to be the area of the base of our box. So when we find the volume, we need the length of the base, the width of the base, and the height is the folding up. So that's going to be this length right here. So we know that this is going to be half, because here's a rectangle, here's this, here's a rectangle, here's a rectangle, here's a rectangle, here's a rectangle. So from here to here is 10. Because remember, the whole thing is 20. So half of 20 is 10. Okay? Next, we want to know this length in terms of x. X being the height of our box. So it's going to be 10 subtract x. And this width is going to be 10 subtract x and x, two x's. So notice that this width cuts out two x's from the total width. This length only cuts out 1x from this total length. Okay, I hope that makes sense to you. So here's our function. Well, we know we're looking for volume. We know that it's a rectangular prism. We should know the volume by now, but in case you don't, it's length times width times height. So our length, 10 minus x, times our width, times our height. Now we could multiply this all together. We'd get a polynomial degree 3 because x times x times x is x cubed. Okay, but we're gonna, for time's sake, we're gonna move on from here. So let's go ahead and go to our graph. I feel like this screen is dim, but I don't have time to figure out how to lighten it or go get another calculator. I'm hungry. So we're gonna go ahead and plug this in. So there's our length times our width. Trying not to hurry. Times our height. Okay. Graphing it, so press enter. Okay. So remember, we only want to deal with from 0, it's going to go up, and it's going to come back down. So I'm going to have to, let's zoom out this time, see what we get when we zoom out. So 5, 4, and we want to zoom out, so 4 again, and I'm going to center it about right in here, I think. Still not high enough. So I want to go even higher. So I'm going to try go to menu, and we'll go to window, and we're going to go to window settings, and I want to make my Y maximum higher. So I'm going to try 100. See if that's high enough. All right, cool. So there's our maximum right there. That's where we're going to find our maximum volume, right up there. So to find that, we're going to go to menu. And Stephen, I hope this works because I want to go to lunch. And we're going to analyze graph. We're looking for the maximum. All right, it says lower bound, so I'm going to go a little bit to the left. It says upper bound, so I'm going to go a little bit to the right. And so now I can't stand this because I can't see the point here very well. So I'm not sure. There it is. Can you see it? It says 2.11, and I'm not sure how to drag that over. I don't know how to grab it and drag it. 96.2. 2.11, 96.2. 2.11, 96.2. So our minimum height would be 0. That wouldn't make a box at all if we cut out x's of 0 by 0. That would be horrible. And then our maximum is going to be where it hits the x-axis again. It looks like it's going to be at about 1, 2, 3, 4, 5. So 5. So from 0, 1, 2, 3, 4, 5. Because at 0, the volume is 0. At 5 inches, the volume is 0. Remember, volume is over here. Volume of our box depends on our height, which is x. Okay? So at about 2.11, about right in here, we're going to have our maximum. So let's see, I'm going to go ahead and go up by 20s. So 20, 40, you could go by 10s. So at 2.11, we're going to have a maximum of 96, about right in there. So it's going to go up and down. These are the most important points. These 2 points tells us where our volume is 0. Okay? So those are not possible. They're not reasonable answers to have a volume of 0. Okay? Everything reasonable in this situation fall in between 0 and 5 inches for height. Okay, and this is our max. So when our height is 2.11 inches, we have a maximum volume of 96.2 cubic inches. So when I ask you for a domain, and we're dealing with an application, we're talking about reasonable, not negative infinity to positive infinity, reasonable. And we know the reasonable domain is going to be between 0 and 5, but not including them, because remember, that gives a volume of 0. That's not reasonable. So we don't include 0 and we don't include 5. Now I haven't done this notation for a while, so I think I'll just use inequality notation from 0 to 5. Range, reasonable. Well, 0 is not a reasonable volume, but I suppose it's possible. But I'm not going to include 0 as part of my range, so no equal sign. You know what, let's use interval on this one. And we're going to go up to 96.2. And we're going to include that because that is the maximum volume, but we're not going to include 0. So here I did inequality notation, and here I did interval notation, just as a reminder of the different notations. Okay, what is the maximum volume? Well, we already found that out, 96.2. And don't forget, it's 3 dimensions, so it's cubic, length, width, and height. Remember, we know that the height represents x, because that's where it gets folded. Here it gets folded up, so x, 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 x all the way around. So we know that the maximum volume needs a height of 2.11 inches. Okay, width. To get a maximum volume, we need a width, and our width number was 10 minus 2x. So that's going to be 10 minus 2 times 2.11. I'm going to lunch. Turn on. Enter. Escape. Help. Calculate. 10 minus 2 times, and then our height, our maximum height. Enter. So 5.78 inches. And then our maximum length, we use 10 minus x. So that's going to be 10 minus 2.11. 7.89, and there you have it. Well, there is one more, and I'm just going to use up the rest of my time, which is not much. It's called the package, and we're trying to find the dimensions of a box for maximum volume that can be sent if the base of the box is a rectangle with a length equal to the side 2 times its width. So I'll get you guys started. I'm going to see if you guys can figure this out on your own. We know that the base of the box is a rectangle. So when you're drawing a 3-dimensional shape, hopefully I do a good job here. We draw a rectangle, and then what I do next is I'm just going to draw a line straight up from the corners. I want this slant to be the same as this slant. Draw a line straight up. Again, I want this slant to be the same as this slant. So they're parallel. Parallel here. Not too bad of a job. Not too bad. All right. So now we know it says that the base, it says the length is equal to twice its width. So if this is the width, the length is twice that amount. So the length is 2w. Now I'm going to let you guys figure this out in class, you and your partner. See if you can figure it out. See you tomorrow in class.